So the nonparametric test that we're going to look at in section 14.2 is what is called the Sine Test. So the Sine Test looks at the central tendency of non-normal probability distributions. And for us, central tendency is going to correspond to the population median here, eta, not mu. Okay, so this is median, the middle value for the data, not the arithmetic mean. So remember, if you have a distribution here, we've got a distribution that's skewed to the right. The median, eta, is in the middle of the data. So this blue area is 0.5, and then this area over here is 0.5. So 50% of the data above the median and 50% below the median. So let's look at an example here. So arsenic is actually a common ingredient used as a pesticide for rice crops. And the FDA safety inspector tests 10 samples of rice for arsenic contamination. We do not know that the population is normal. So that's your clue. Or if they just don't say anything at all, that's going to be your clue that we want a nonparametric test. Perform a hypothesis test at alpha is 0.05 to determine if the median arsenic level is less than the action level of 100 parts per billion. Also, that's another clue. They're asking about median. Hypothesis test on median is going to be nonparametric. So our sample arsenic levels in parts per billion are here. And so we first want to set up H0 and HA. So our null and alternative hypothesis. So what we're trying to establish here, or we hope to establish, is that the median here is less than the action level of 100. So what you're trying to show is your HA. So that's going to be eta less than 100. If that's not the case, then eta is going to be equal 100. So there's our H0, HA. Our test statistic we're going to denote with the variable S, and that's going to be the number of measurements in the sample that are less than eta 0, which is our 100. So we just count how many we've got here. So 1, 2, 3, 4. 4 values here are less than 100. So this number is equal to 4 for our example. And then our decision rule for the Sine test, we're going to reject H0 if the p-value is less than 0.05. Now note that S, the number of measurements less than 100, is actually a binomial random variable, because either for each value that you look at here, it's either less than 100 or it's not less than 100. So if the null hypothesis is true, then the binomial probability p, that the value is less than the median, is going to be 0.5. So this is binomial. You're finding your p-value here using the binomial distribution with p equals 0.5. So that means that our p-value here, which is the probability of the result, that we get a result that's as contrary or more contrary to the null hypothesis than this sample, is going to be the probability that x, the random variable, is greater than or equal to s, which was our test statistic. So this is always the case whether you're looking at upper tail, lower tail, or two-tail test. So, and then this x is a binomial random variable. Okay, so we're going to use binomial probabilities to compute this. So this is actually, our s is 4, so this is the probability that x is greater than or equal 4. And remember, with binomial probabilities, you always have to write them in terms of a less than equal. So we'll do 1 minus the complement probability. If you're not greater than or equal 4, you're going to be less than or equal 3. Actually, strictly less than 4, which means less than or equal 3. Remember, you will always want to write binomial probabilities in terms of a less than equal. And then this binomial probability we can figure with binomial CDF. So this will be 1 minus binom CDF. And then we have 2, 4, 6, 8, 10 data values total. So 10 trials. Our probability is 0.5. and we're looking for at most 3 successes. Let's go ahead and put that into the calculator. So go to second variables. We want to do 1 minus first. 1 minus. Now we'll go to second variables. Come down to binom CDF, which is option B. Trials are 10. P is 0.5 and X is 3. Paste it. 0.8281. So this is equal to 0.8281. That is definitely greater than 0.05. So we do not reject H0. Remember, small p-values are statistically significant. So what does it mean that we do not reject H0? So we're going to accept H0 that eta is equal to 100. There's not sufficient evidence. So there is not sufficient evidence to conclude, and you always refer to the alternative hypothesis. So in this case, to conclude eta is less than 100. So there's not sufficient evidence to conclude that the median is less than the action level. So we would conclude that it's at or above the action level. So that's a Sine test. That's how you complete a Sine test. So here's a general setup for a Sine test for population median. Your test requirements is your sample is selected randomly from a continuous probability distribution. For a one-tailed test, your eta is equal to eta 0, so a default value. For an upper-tailed test, it'll be eta greater than that default. For a two-tailed, it'll be not equal. Your test statistic is the number of measurements greater than eta 0 if it's an upper-tailed test. For lower-tailed, it'll be less. Make sure your test statistic matches your alternative hypothesis. So this is greater, this will be greater. If this is less, this will be less. Now for the two-tailed test, we define S1 to be the number of measurements less than eta 0. S2 is the number of measurements greater than eta 0, and then your test statistic is the max of those two. You're going to ignore observations that actually equal that default value. And then your observed significance, your p-value, is probability x is greater than or equal s. Now for two-tailed, you have to multiply by 2. And then x is your binomial random variable with p is 0.5. You reject H0 if your p-value is less than or equal to alpha. In our case, we were doing 0.5.